All right, so for your test tomorrow, I had a couple of people ask me some questions that were the same ones. So I'm basically just going to go over 4 problems here. The first one here, this is from the paper that said AP Calculus AB Particle Motion Worksheet. Numbers 1 to 5, you had to find these A through G parts. And then number 6 was the enrichment one, and then on the back were all the answers. So that's what we're going to start with here. So let's see what we got. First of all, this is number 4. We want to find the velocity, which is just the derivative of your position. So the velocity function here, we take the derivative of this. We're going to end up with 6t squared minus 28t. Try that again, 28t plus 22. What is the velocity at 3 seconds? So just take your calculator. Like I said, this whole test will be a calculator test. There is no non-calculator part. So take your calculator, plug in 3, and we find out that V of 3 gives you -8. We want to make sure we have the units there, so meters per second. When is the particle at rest? So the particle is at rest when the velocity is 0. So what I did was I took 3t squared, divided everything by 2, minus 14t plus 11, set it equal to 0. So what I got here was t minus 1, and then 3t minus 11 equals 0. So my 2 zeros then are t equals 1 and t equals 11/3. C says, when is the particle moving right? When is it moving left? I'm going to jump down here to F. When is it speeding up and slowing down? And I'm just going to do a table with all of those. That's going to help me answer 2 parts of this. So for in my table, I have some t values. And then the velocity, and I will eventually do acceleration to answer the speeding up and slowing down. So I'm going to, actually I'll come back to that problem. What's the acceleration function? Acceleration A of t. Make sure that you go back to this problem, because when I did this I was looking at my factored when I divided 2 out. So make sure you don't make the same mistake as me. Go back up to that beginning one, 12t minus 28. What is the acceleration at t equals 1? Plug 1 in there. A of 1 gives you -16. Again, we want units. Units for acceleration is meters per second squared. Just the seconds is squared, not the meters. It's just the denominator. What is the displacement and total distance? So the displacement and total distance here. So first of all, I should have left way more room here because this is not really enough space to do this, but I will show you. Displacement is just the final. So S of 6 minus the initial, which is S of 0. So S of 6 was 55 minus S of 0 was -5. So we get the total displacement of 60 meters. So that's just where it ended minus where it began to get the total displacement. Now, if you look at the graph of this, let me pull up the calculator here. When you look at the graph of this, you can clearly see that this function, if we look at the position function, it moves. It's a cubic function, so it goes up, down, up. So what we want to do is we want to take all of the points where this is moving down, and we want to split it up over that. So basically what we're looking at here is kind of like the absolute value of these different distances, okay? So when I set this up, what I did was I did the first part. See if my calculator's here. I don't know where it's at. It didn't come up yet. There it is. So is that the function? No, that's not the function. Let me move over here because it's got some of the right parts. So let's make this 14 x squared plus 22 x minus 5. So when I set my window, when I did this on my calculator, not on the one online here or on my computer, I set it like that, and then I set my Y min. I did negative 20 to 20, even though we're not going to be able to see 6, because when you plug 6 in, you end up getting 55, as we found out from this part right here. I don't know what keeps happening to that when it disappears, but just pull it up like this, I guess. Okay, so you can see at these values right here, okay, this value right here and this value right here, this is where it's changing. So in the original position, we can see that it's increasing, it's moving in a positive direction here. Once it starts to change direction, this is where we want to split it up. Now, those numbers should look familiar to you because that's where the velocity is 0. So we could also look at the velocity function, which was 6t squared minus 28t plus 22. And if we look at this, anywhere that this is below the x-axis, or the t-axis, sorry, the t-axis, that's where it had changed direction. And this down here would represent a negative displacement. So we want to take the absolute value, and we basically want to look at the kind of like the speed. Okay, so we want to see, we're basically going to move that up. So now what we're going to do is we're going to take the absolute value around these numbers, which we know that's 1, and we know this is 11/3. Okay, so the blue and the red graph here, the red is a derivative of the blue graph. So hopefully you recognize that, and that's kind of part of the reason why I put these two in the same section. All right, so let's go through. This is what I did now for this, for total distance. Okay, so this will be what's in green. So I did the absolute value. I went from, in the first section would be 1, so S of 1 minus S of 0, absolute value, plus, and then I split it up around that 11/3. Okay, so I went from, again, I'm doing final minus initial, so 11/3 minus S of 1, and then I added the last part, which was the final was S of 6, minus the initial at the last section was S of 11/3. Okay, now when I did this, unless I messed up when I plugged it into my calculator, I ended up getting 87.926, and they got 97.926. So because this first part, like the first one here, S of 1, when you plug 1 in, I got 5. I got 5 when I plugged 1 in. And again, I could have made a mistake when I entered this in here. I can't find my calculator. Oh, there it is. So if we look at, basically I kind of looked at the table here. So when you plug in 1, you get 5. When you plug in 0, you get -5. So that makes the first section 10. The second section you get, what did I get there? -3, well, -377 over 27 minus 5, which if you plug that in your calculator and get your absolute value, I ended up getting I'm just going to say it's just 3 decimal places, 8.923. And then the last section, S of 6 is 55, and then plus, maybe that's, let me check this, I'm sorry. Because I ended up, no, I got 68 for that one. So I think that their answer was incorrect, because the last part here, I ended up getting 68 point, we'll call it 963. So yeah, when you add all of these together, like I said, I ended up getting 87.92. It's 925, 925. If you use the actual numbers and not the rounded like I did, you get 87.925 repeating. So I don't know if, I mean, maybe you guys can find a mistake that I did here, but they ended up with 97, and I don't know where they got their 97 from. Because when you break it apart into different pieces like that, that's what you're going to end up getting is the 87. So maybe it was a typo on their part, where they had 97 as the answer. So I'm not sure, but I got 87, and I don't see a mistake that I made there. So I'm going to go with 87.926 when it's rounded to 3. Okay, so now to answer F and C, moving right, moving left, speeding up, slowing down, this is where I will come to my accelerate or my table here. So the acceleration is 0, I'm going to find the velocity when acceleration is 0. But the acceleration is 0 at 28. Like if we set that equal to 0, 28 over 12, you end up getting 7 over 3. Okay, so the acceleration, not when you plug in 0, but A of t is equal to 0 when t equals 7/3. So I say that I kind of out of order. I know I'm jumping around here a little bit, but I'm saying that because we need to plug that into our table. So we need a number less than 1, so I used 1/2. 1. A number between 1 and 7/3, I used 2. And 7/3. A number between 7/3 and 11/3, so I used 3. And then a number bigger than 11/3, but we want to keep it less than 6, so I used 5. So this was a 0, this was a 0 in the velocity, and this was a 0 in the acceleration. When you plug 1/2 into your velocity, let's come up here. If we plug 1/2 in here, we get a negative and a negative, so that's positive. So this one here is a positive. If I plug in one of these 3 numbers, like let's say if I use 3, I get positive and negative. So that's a negative, which means they're all negatives. Oops. And if I plug 5 in, I'm going to get a positive. Positive times positive is positive. Now in my acceleration function, right here, 12t minus 28, let's plug in 1/2, so I get 6 minus 28, which is a negative. Or you could plug in 1 or whatever. But these are all negative, and then if you plug in 3, you get 36 minus 28, which is positive, so those are all positive. All right, now I can answer part F and part C. When is the particle moving to the right? That's when it is positive. So it's moving to the right from 0 to 1 and 11/3 to 6. And it's moving to the left in between there, so from 1 to 11/3. Okay? So, yeah, I think that's everything there. All right, coming down to F, when is it speeding up? It's speeding up. I'm just going to abbreviate this, speeding up whenever the signs match. So from 1 to 7/3, and from 11/3 to 6. And then it's slowing down wherever the signs are opposite. So from 0 to 1, and from 7/3 to 11/3. Okay? So the last thing we have to do here is finish out G, which says find the velocity when the acceleration is 0. We know the acceleration is 0 when time is t equals 7/3. So we're going to plug that into our velocity. So we're going to find the velocity of 7/3. And when you plug that in, you're getting a -10. We're going to round this to 3.667 meters per second. So there you go. That's your answer for G. All right, so I know I kind of skipped around a little bit there, but hopefully you can follow along with what's happening. And if not, send me an email, let me know, and I'll talk about it a little bit more, whichever part you need to see. Okay, number 6. You are given these in this problem, but this is not something you are given on the AP test. We don't even need velocity because we can take the derivative of position. But when we talked about this before, the position function, I like writing it the other way just because that's how I'm used to quadratics being written in standard form, and you probably are as well. But it's -1/2 times gravity, which, well, I'll just write as g, t squared, plus your initial velocity, so v sub 0 of t, and then plus your initial height, okay? And you're given all that information in this problem, but I'm saying that now because it's not something that you're given in a typical problem, especially on the AP test and on any of my tests. That's something that you'll need to know. And this is something that we had covered earlier in the year. I mean, you're going back to, I don't know, maybe the middle of chapter 2, I think, when we talked to, or early to mid chapter 2, when we talked about that. Now, you're also given gravity is approximately 32 feet per second squared. If we're talking about calculus, typically it's in this units, but physics, it's in meters per second squared. But you're going to look at the information you're given in the problem. Since this is feet per second and this is feet, we're going to use that 32. Okay, so I did not leave myself space to do these problems here, so I will, I'll just write them down here below. So A, find the position of the stone as a function of time. So S of t is equal to -1/2 times 32. Like I said, these are typically going to start out at -16t squared. Plus 300t plus the initial height, which was 6. Make sure they're all in the right units, okay? If it says 6 inches or, 300 inches, I'm sorry, 300 feet per minute, we want to make sure that they're all in the same units, okay? So that's one key piece of information there. B, find the velocity. All we're doing here is taking the derivative, right? We don't need another formula for that, just take the derivative. -32t plus 300. Find the velocity at t equals 2 seconds. So we're going to plug 2 in there. So we're finding v of 2. Plug it in, just use your calculator, okay? -32 times 2 is -64 plus 300 gives you 236. Make sure you have units, feet per second. Now, D is the one I did, I went through and I put it into, I'm going to show you the way I did it. But then I looked at their answer and I'm like, wow, that's way easier to do that. Remember, the maximum height occurs whenever, maximum or minimum always occurs when the derivative is equal to 0. Well, we already know the derivative, so if we set this equal to 0, we'll get that time is equal to 9.375 seconds. And then we can take that and plug it back into here to get our height, and that will give us our maximum height. When I did this, I was thinking algebra, I was thinking, all right, I got to find the vertex, and I went through the completing the square process to get that. So I'll show you what I did, but the way that they have it in their answer key is far easier. I was not thinking in calculus terms, I was thinking in algebra terms. So I'm going to show you my thought process, and if nothing else, it's a good review of completing the square. So, all right, now, when we're doing completing the square, first of all, anything that has a variable, we need t squared to be a coefficient of 1. So I'm going to divide that out, which 300 divided by -16 is 75 over 4, plus we're going to leave a space there, and then leave the 6 out there. Whatever we put here, we'll have to put here, okay? So take your middle term, 75 over 4, divide it by 2, so 75 over 8, and then square it. 75 squared is 5625, and then 8 squared is 64. Multiply that by -16, which gives you -5625 over 4, and then we're going to subtract that out here, so it actually ends up adding 5625 over 4. You could use decimals, doesn't matter. I just like fractions, so I left it as a fraction. So then we have -16t minus 75 over 8. Guess what 75 over 8 is? 9.375 squared plus 6 plus 5625 over 4 gives you 5649 over 4. So this is the time. So when t is equal to 75 over 8, which is 9.375, the maximum height will occur at this 5649 divided by 4, which is 1,412.25 feet. So again, I did that. I feel like I know I did that the wrong way. Not the wrong way, but the long way. What they did was way easier. If you see max or min, again, like I said, I wasn't even thinking about the stuff that we had just done. My mind went back to algebra. Either way, you get the same answer. It doesn't really matter, but what they did up here, I would feel is a much faster way of doing it than completing the square. So that's what I would recommend you do, is if you're trying to find a max height, instead of going to the vertex, just take the derivative and set it equal to 0, and you get 9.375 seconds. Just make sure you remember to plug it back in to get your maximum height, because that's what you're actually asked about. Okay? This kind of looks like a capital A. It's supposed to be feet. Feet. There we go. Okay, so that was all from that worksheet that I got questions on. The other thing was the worksheet, I believe it was worksheet 39 where they had these. I specifically or intentionally left out the answers to this. They gave you some multiple choice answers, but honestly, I didn't get any of them. I got 2.050, which the closest answer they had was 2.55. So again, I did this problem twice, and I could not find a mistake that I made, but we want to find the velocity when the acceleration is 0. So we're going to set the acceleration equal to 0. So let's first of all get the velocity. So the derivative of this would be 4 sine t minus t. If we bring this exponent down, it'll cancel with the 2 and leave us with t. The derivative of 10 is 0. So there's your velocity. We need to get the acceleration now. Take the derivative of that again. Negative 4 cosine t minus 1. So we will set this equal to 0 now. So negative 4 cosine t minus 1 equals 0. That means cosine t, add 1, divide by negative 4, get negative 1/4. So t is equal to cosine inverse of negative 1/4, which gives you an approximation of, come on, there we go, 1.823476582. So I left that in my calculator, and what I did was when I entered this part here, I just used 4 sine, and then you can use the answer button, which is second and then the negative sign. But also you could just plug this 823 in. Minus 1.823. Okay, so that is your answer. I'm just going to type it in here again just to make sure, 1.823, just to make sure I didn't make a mistake again while typing this in. And I'm still getting the same answer. So this, like I said, I got 2.05. If you use 1.823, this is what you get. If you use the actual one, like the whole thing, if you plug that in, you get 2.0495, blah, 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 blah. But either way, it still rounds. 3 decimal places, it still rounds to 2.050. Again, make sure you include that last 0. It is showing me that you rounded to 3 decimal places. So yeah, like I said, their answers, the closest one to that was 2.55. And I'm not sure if they typed it in incorrectly or what, but yeah, I couldn't get that. I tried it a couple different ways and looked at it on the graph, and I still was not able to find that 2.55. So I got 2.05. So I'm going to say that there is a typo on that one also. Maybe not. I don't know. Maybe I made a mistake in here that I'm not picking up on, but I don't see it. The last one, number 7. Suppose that a car travels along a straight road. Here's your velocity, t squared minus 4. from 0 to 5. The first thing that we are asked to do here is to sketch a velocity function. So this is a, here we go. Should have put a grid on here. 1, 2, 3, 4, 5. 1, 2, 3, 4. So if we're sketching this, t squared minus 4 drops down 4, and this is going to be an upward facing parabola. It's also going to cross through 2 because that's one of the zeros. So we're going to have a function that kind of looks, I mean, if I had actual grids here, it would look a little better, but we get the idea there, right? So during what times is a car traveling in the negative direction? If you look at the position function, so if we're starting with this being the derivative, right, this is our velocity in time graph. If we look at the position of this, we can graph what that looks like. This here would be a max or a min. These are negative going to positive, so if it's negative positive, that's a min. So let's say we have a min here. So this would come down like this and then go back up, keeping in mind that the blue graph would be a cubic function because this is a squared function. Yeah, basically it would kind of look like this just from 0 to 5. It could have other stuff going on outside here, but from 0 to 5 it would still kind of look like a parabola. But anyway, negative direction is whenever the slopes here are negative of the blue or when the values of the velocity are negative. So it's in a negative direction from 0 to 2. That's when it's negative. And it's in a positive direction whenever the velocity is positive. So that would be from 2 to 5. Okay, we don't know anything beyond that. At what time does the car change direction? And that happens at t equals 2 seconds, right? Right in between these two is where that's going to occur. So that was all that you needed to do for number 7. You didn't even need this blue graph in here. I know sometimes that can help with the explanation, and especially when we go into chapter 4, there's something special about these values right here that we will talk about when we get into chapter 4. And I didn't have another graph. Never mind. So you'll see that on the notes for Friday that there is something special about that we will talk about a little bit more in detail. But for now, we can answer all these questions using the information that we know. Okay. So if there are any other questions that you have that you did not ask, please let me know so that I can answer them before your test tomorrow. But yeah, just let me know. Otherwise, we'll do the test tomorrow. I'll send out an email with some information for those of you that are doing your test remotely for the first time. Just basically what my expectations are for that. I'll send that information out to you. Yeah, like I said, if you have any questions, just let me know.